In this video, we look at unit ratios and scale factors. Now, this idea comes up in scale diagrams of things. It comes up in the idea of maps and making models of things. But first, let's look at a simple example. Here's a diagram of an ant. Here's a picture really of the real ant, let's say. So in this case, the diagram of the real thing is bigger than the real thing. Now, by how much? Well, we can look at this in terms of a ratio. The diagram to real is, if we put in the numbers we've been given here, 2.75 to 0.55. And then we can simplify the ratio. Usually in this sort of we make it as something is to 1 or 1 is to something. Let's make it this smaller number 1. To make it 1, we have to divide by 0.55. So if we're going to divide this bit by 0.55, we have to divide this bit by 0.55. So when we do that, we find 0.55 divided by 0.55 obviously is 1. 2.75 divided by 0.55 is 5. So the ratio of the diagram to the real here is 5 to 1. Or sometimes we say the scale factor is 5. The diagram is 5 times the size of the real thing. Or any measurement in the diagram is 5 times what it is in the real thing. So let's look at a couple of examples. The head of a real ant is 0.12 centimeters long. How long would it be in the diagram if the scale factor is 5? The thing to realize, of course, is the diagram is larger than the real ant. So what we do then is we multiply the length by 5. So the diagram length will be 5 times this measurement, 0.12, which we work out on our calculator, is 0.6 centimeters. So in the diagram, the head would be 0.6 centimeters long. Now what about this one? A leg in the diagram is measured to be 1.5 centimeters. How long is it on the real ant? And again, we've got a scale factor of 5. Well, now we're going the other way. We're going from the diagram to the real ant. So the real ant's length of the leg will be smaller. So we have to divide by 5. The real ant is smaller than the diagram. Therefore, we divide by 5. So the real length of the leg will be 1.5 divided by 5, or 0.3 centimeters. Or timesing by 10, it's 3 millimeters. Now let's look at another situation where the diagram of the real thing is smaller than the real life thing. A map obviously is a representation of real life, but it's smaller than the real life, of course. Now, if we look carefully on here, we can see the scale is 1 to 7,500. That means the map to real life is 1 to 7,500. So again, we say the scale factor here is 7,500. Real life length is 7,500 times the corresponding length on the map. So here's an example. Find the length of the block of land on which Concordia sits using this map. And the scale on the map is 1 to 20,000. In other words, the real length of the block of land will be 20,000 times what we measure it to be here. Now I've measured that with a ruler to be 2 centimeters. So we have to times our 2 centimeters by 20,000. Measured to be 2 centimeters. So the real length is 2 times 20,000 centimeters, which is 40,000 centimeters. Now we don't have much idea of that, 40,000 centimeters, so we should convert it to suitable units. To change centimeters to meters, we're going to divide by 100. And divide by 100, we cross off 2 zeros. So the length of the block of land that Concordia sits is about 400 meters. In going from the map to real life, we multiply by the scale factor. And the last example, going the other way, this is the start of a map I'm making of a paddock. I want to show a circular dam at the point X here. That's where the centre of the dam is going to be. And I know that the real dam is 25 metres in diameter. With what diameter should I draw the dam on the map so it represents it accurately? Well, in this case, the map length is less than the plan, so we divide. 25 metres divided by scale factor, 2000, will tell me how big I need to draw the dam on the map. And that'll be in metres, because I started the length in metres. Dividing by 2000 is still in metres. On the calculator it's this, 0.0125 metres. That doesn't help me draw it very much. I need to convert it to suitable units, so timesing by 100, change to centimetres, move the decimal point 2 places, and we'll see it's 1.25 centimetres. I have to draw my dam here with a diameter of 1.25 centimetres. So when I do it, that's what it will look like. 1.25 centimetre diameter is my dam. So there is some examples of where scale factors and ratios are used in scale diagrams, in maps, and also in models.